Hi KCET 2025 aspirants, so welcome to our top 30 series, and in today's video we are going to solve top 30 previous year questions and most expected questions from the chapter General Organic Chemistry. So General Organic Chemistry means some basic the chapter of organic chemistry, the fundamental chapter of organic chemistry, some basic principles and techniques. So we'll be discussing most important questions here. So basically you will be getting questions from isomerism and nomenclature if I see the last 10 years of papers. So please focus on these topics, that is isomerism and nomenclature. Okay, so we have incorporated such questions in this video. So let's get started with the first question. The correct IUPAC name of the given compound. So whenever you name a compound, the basic thing that you should be doing is the proper numbering of the chain, right? You should give the proper name to the proper numbering to the longest carbon chain, right? So if I see here, I have 1, 2, 3, 4, 5 and 6. I can get the longest carbon chain like this. So I have like this 1, 2, 3, 4, 5, 6, and here I have CH3 and here I have CH3. 1, 2, 3, 4, 5, 6. So how can I write this one? 3, 4 dimethyl, right? Hex. So I can see on the third position 1, 2, 3, 4, 5 and 6. Okay, so you can name it, number it from any side. So 1, 2, 3. So 3, 4 dimethyl hex 3ENE, option number C here. Okay, I hope all of you are doing it correctly. Next, the correct IUPAC name of, so we have been given with a compound here, CH3, CH2, CCH3, I have H here, then I have CH and I have CH2, CH3, and then I have CH2, CH3. Now if I want to find the longest carbon chain here, 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. Now if you see, I can number from this side also, 1, 2, 3, 4, 5, 6. The substituents here also are coming on third and fourth. If I count from this also, the substituents are coming on third and fourth. Then the rule says that the substituent which comes first in the alphabetical order, you see this is ethyl and this is methyl. So ethyl will come first in the alphabetical order. So ethyl should be getting the smallest number. Okay, so that means if I want to number it, it will be 1, 2, 3, 4, 5 and 6. So I have what? 3 ethyl, 4 methyl. Okay, 3 ethyl, 4 methyl hexane, option number B here. Okay, I hope you understood why the other chain numbering is wrong, because if I number it from this side, methyl will get 3, ethyl will get 4, right? But alphabetical order which substituent comes first, that should be getting the least number. Okay, so that is the point. Okay, before going to the next question, here I have something very important announcement. So you know that we are just left with few days for the exam, and at this point of time it is very, very important and critical to do more question practice, right? So to help you with this, we have launched our best test series, that is our Abhyas KCET 2025. In this test series, you are getting 35 mock tests, which includes both paid like part test and full length test. You will also be getting one-shot revision videos, doubt clarification classes, as well as detailed video solutions, and all this you can avail at a very, very discounted price of just rupees 1498. Okay, so you can see all the details. Many students have already taken this test series and have boosted their preparation. They're already ahead of you. So if you don't want to lose this opportunity, click on the link given below in the description section and go and register right now and purchase the test series. Now coming to those students who are also writing Comet K, for them we have something very special. Already we have in our YouTube channel Comet K Launchpad, we have already launched it. And for the, like, if you want proper preparation for Comet K, we have also a 21-day crash course for Comet K. There you will be getting entire syllabus coverage will be there, right? Apart from that, 12 mock test is there. Live doubt solving classes will be there. You will be getting all the notes and everything in the PDF format. Revision videos will be there. So everything will be provided in proper format, everything. So if you want to join our Comet K crash course, that also you can do, and the price for this one is just 1999. Okay, which is again a very, very affordable price, right? Now Coming to the next question, the IUPAC name of the given compound. So if I have CH3, CHOH, COOH. Now see, here OH is not the main functional group. COOH, that is acid group, is the main functional group. So if this is the main functional group, then what will happen? This one will act as a substituent. So if it is a substituent, whenever OH is behaving as a substituent, we use the word hydroxy. So I have here, this is the next carbon to the functional group. So this is alpha carbon. So I have alpha hydroxy propanoic acid, option number B. Okay. Oh, one more thing, sorry. The question is asking, this is common name. When I am using alpha, that is a common name. But the question has asked me to find out IUPAC name. So I will just number it 1, 2 and 3. So I am getting 2-hydroxy propanoic acid, option number D. Okay. So what is this one? This is your common name. Okay. Next, we have again IUPAC name question from the following compound is. So now a question may arise how to number it. So if I have this one, okay, I want to write it in terms of, I have CH3, okay, next carbon I have CH, next carbon I have CH3, next carbon I have OH, and then next carbon I have CH3, right? This is the structure given. I am very sure. 1, 2, 3, 4, 5. 1, 2, 3. 1 second. 1, 2, 3, 4, 5. So I have CH3, CH. Okay, this C is not there. Okay, just a minute. Let me. So CH. Then on this carbon I have a CH3 group. So there is no H here, okay, got CH3, then I have C here, and then I have CH3, and I have OH, right? So now if you see that I can number it from this side also and this side also. If I number from this side 1, 2, 3, 4, OH will get on the 4th position. If I number from this side 1, 2 will be the OH group, right? So OH group here is the main functional group, so it should get least priority. So 1, 2, 3, 4 and 5, okay. So I have here 3 methyl, okay. So 1, 2, 3. So I have okay, one more thing, just a minute. Let us solve the next question here. This is a very important and tricky question. So first let me draw the structure. I have CH3, okay, then I have C, on that I have OH, right, CH3, C, OH, next carbon I have double bond, okay, and then next carbon I have CH3. So here I have 1, 2, CH, okay, here I have to add CH3. Okay, so now if you see that I just want to number it, so the carbon which is, you can see the options, you have 1, 2 dimethyl but 2 en 1 ol, okay, 3, 4 dimethyl but 2 en 4 ol, alpha hydroxy, that is not a IUPAC name, we can remove it, 2, 3 dimethyl pent 3 en 1 ol. So first of all, you should remember that the OH group should get the least number because it is a higher priority group. So if I want to number it, the first one 1, 2 dimethyl means it is numbered like this 1, 2, 3 and 4, okay. So I have on the first carbon 1, 2, 3, 4. So 1 and 2 dimethyl but 2 en 1 ol, okay. So I have to give the first number to here, so option number A is the correct answer. Now if I see 3, 4 dimethyl, 3, 4, how will I get? 1, 2, 3, 4, right? That means OH you are giving the least number, which is not correct because it is a higher priority group. Next 2, 3 dimethyl means you are starting numbering from oxygen, 1, 2, right? Yes, 2, 3 dimethyl. So we have 2, 3 dimethyl pent, 1, 2, 3, 1, 2, 3, 4, 5, okay, 1, 2, 3, 4, 1, 2, 3, 4, 5. So 2, 3 dimethyl. So this substituent numbering is given wrong. So this is also not correct. The correct answer or the appropriate answer will be option number A. Okay. Next, IUPAC name of the given compound. Again we have this one. So you can see I have a structure like this: CH3, C double bond O, CHCl, CHI, COOH, right? So you have 2, 3 on 4 and 5th. So you have substituents on 2nd, 3rd and 4th carbon. So it is, you have to arrange it in alphabetical order. So I have 3rd, first is chloro. So 3 chloro, 2 iodo, 4 oxo. Okay. So whenever ketone is a substituent, we have to use the word oxo. So 4 oxo pentanoic acid, that is option number D here. Okay. Next, which of the following species is an electrophile? So what is electrophile? Electrophile are those which are electron deficient species. Okay, they are electron deficient, means how will you identify whether they are electron deficient? They will not have no lone pair. No lone pair of electrons are available. Now if you see water, it has lone pair, so it is a nucleophile. Ammonia, nitrogen has a lone pair, it is a nucleophile. So this is nucleophile, this is nucleophile. Here if you see, this oxygen also has lone pair, so this is also a nucleophile. Now if I see sulfur, sulfur has 6 valence electron, right, and it is forming bond with oxygen. So if you remember the structure, sulfur structure is like this. So sulfur has no lone pair. Okay, so it cannot donate electrons, so it is not a nucleophile, but it has, if you see sulfur electronic configuration, 2s2, 2p6, 3s2 and 3p4, right? I think 16, 6 plus 4, 10, 11, 12, 13, 14, 15, 16. Now if you see 3s2 and 3p4. Okay, so what happens now? Sulfur also has vacant 3d orbital. Okay, sulfur has vacant 3d orbital where there can be bond, where there can be electrons can be donated or it can accept electrons there. So it is a electrophile, option number D. Clear? Next is question number 7. Which one of the following series contains electrophiles only? Okay, so if I see H2 is a nucleophile, I can eliminate. NH3 is a nucleophile, eliminate. H2O is a nucleophile, eliminate. Now you have only one option left, that is option number C. Now aluminium chloride, what is the speciality of aluminium chloride? It is a Lewis acid. Okay, it is a Lewis acid and it has incomplete octet. Incomplete octet. Now whenever any species has incomplete octet, it has the tendency to accept more electrons because it is not having 8 electrons in the valence shell. So it can behave as a Lewis acid. Okay, or electrophile. Cl, it and then SO3, just now I discussed. NO2 is also electron deficient, so option number C. Okay, next question number 8. Which of the following alkyl groups has the maximum plus I effect? So what is plus I effect? Inductive effect, right? So inductive effect, you remember, if I have more alkyl groups, then it will have more plus I effect. Okay, so I have this one. If you see here, I have how many carbons? 4 carbons, right? Here I have 3 carbons, 2 carbons, 1 carbon. More alkyl group, more donation, more plus I effect, option number A here. Next, the central C atom of an alkyl free radical possess. Now if you see, suppose I have a molecule like this, CH3Cl. Okay, the central carbon atom of an alkyl free radical, suppose this bond has cleaved. Okay, so what I will get? CH dot plus Cl dot, right? I'll get there. Now this species has how many electrons? You can see 3 bonds are there, 1, 2, 3, 4, 5, 6 and 1 electron here. So total 7 electrons are present. So option number C. Okay, next Question number 10, the inductive effect or the plus or the inductive effect decreases with the increase of distance. Yes, that is the correct statement, option number A. Let us see the example. Suppose I have a compound like this. Okay. Now fluorine is more electronegative, so it will pull electrons. We will have delta plus charge here, delta minus charge here. Now what happens when now this becomes plus, so this will pull the electrons, so this will become delta plus, right? So this inductive effect here is more as compared to here, because here fluorine is withdrawing, here a carbon will withdraw, right? So that is why as we move further, the inductive effect decreases, the strength of inductive effect decreases. So that is why option number A is the correct statement. Next, the non-reactivity of chlorine atom in the compound is. So now if you see this compound, what happens? This chlorine is tightly bound. This chlorine is tightly bound to carbon. Why? Because here we can see chlorine is having lone pairs of electron, so it can come here, it can come here. Due to resonance, what I will get? I will get a structure like this. Okay, so you can see this is a double bond, right? And double bonds are very difficult to break, these are very strong, so the reactivity decreases. Okay, so we have here that is due to resonance effect, or option number C here. Okay. Next, the CC bond length in propene is little shorter, 149 pm, then pm means picometer, than the CC bond length in 154 picometer in ethane. This is due to. So if you see, the question is saying the CC bond length in propene. So I have suppose CH3, CH2, this CC bond length, okay, and then I have here ethane. Okay, the CC bond length in propene, this is 149 picometer, whereas this one is 154 picometer. What is the reason for that? So here what happens, if you see, we get something called as hyperconjugation effect. Now what is this hyperconjugation effect? See, in case of this one, this CC double bond, first of all, let me tell why other effects are not possible. Now plus I effect, there is no role of plus I effect here. Mesomeric effect, we can't find resonance. Electromeric effect, we cannot find any electromeric effect here. So due to hyperconjugation, what happens? This bond becomes more stable. Okay, more stable, more tight, so their bond length, more stronger bond is formed due to the hyperconjugation effect. So this bond length decreases, option number D here. Okay. Next, which of the following groups becomes to minus I group? Minus I group means it is electron withdrawing. Electron withdrawing, right? So you can see that these all will donate electron, but this one is electron withdrawing in nature. Why? The first reason is here is the carbon here is sp2 hybridized and it is electronegative in nature. Okay, so option number A. Next, the IUPAC name of the given compound. Okay, so if I want to name it, so first thing I have to do is proper numbering, and you know COOH is a strong group, is a very strong acid group, and it has the highest priority in the nomenclature. So I have 1, 2, 3 and 4 and 5, 6 and 7, right? So I can number it as 3 amino, right? On third position I have amino, so I can see 3 amino hept. Okay, hept means because I have 7 carbons, hept. Then 5 I have double bond, so 5 En oic acid, that is option number D. Okay, next, this is a previous year question, IUPAC name of the compound 2023, very simple question, just number it 1, 2, 3 and 4, right? So I have 2,3-dimethyl but 2-ene, 2,3-dimethyl but 2-ene, option number A. There is nothing to explain. You can see first, if I see carbon is 4, so that is why the parent name has to be but, right? So I can eliminate this option, and these are the substituents at second and third position. So 2,3-dimethyl but 2-ene. Next, Which of the following represents the systematic name of the compound given below? So you have to see which is the correct name for this compound, right? So I can see 1, 2 and 3. Okay, or I should number it from this side. So if you remember, double bond has more priority than chlorine group. Okay, so I should be numbering it in this way, not from this one. Double bond should get more priority. Okay, so 1, 2 and 3. So I have 3 chloro prop 1 ENE. Okay, option number B. C. B is, you may get B as the answer because if you number it from this side, 1 chloro prop 3 ENE is definitely wrong. It is prop 2 ENE. If I number from this side, it is prop 2 ENE. But again, when we have double bond and chlorine, double bond will win and that should get the least number. Clear? Okay. Next, another IUPAC name. We have 1, 2, 3, 4 and 5. Right? So here, if you remember, we can name it what I'll say, 1, 2, 3. The main name, ketone is a like major functional group here. So the name should end with ketone, means ONE. Okay, alcohol is not the major functional group. When we have 2 functional groups, you have to see which is more priority or which is more dominant. So we can see that this one, if you see the order spectrochemical series, CO is a more dominating one and then OH. Okay, so I have this one, definitely it will be pentane 3-ONE, pentane 3-ONE, and I can remove the other 2 options. Okay. Now if I see, I have hydroxy at the first position because it is a more important functional group. It should get the least number. So I have 4-methyl, okay, 4-methyl 1-hydroxy pentane 3-ONE, option number A here. Okay. Next, which of the following is not a pair of functional isomers? So functional isomers means 2 compounds which is having same molecular formula but different functional groups. So for example, if I see CH3, CH2OH and CH3OCH3, they are functional groups. One is alcohol, one is ether. Now if you see this one, NO2 and NH2, CH2 and COOH, these are not functional groups. This can also be functional isomers. The formula is same. Here it is an amine, here it is a nitro functional group. Here if I see that this one and this one, you see these are, both of them are ethers. Okay, they are not functional isomers, rather they are called as metamers. What do you mean by metamers? See, metamers means if I have certain functional group like this where ether, right, R-OR. If the sides, if the groups present on the sides of the oxygen are different, then we call it metamer. So here you can see, here I have 2 carbon, here I have 2 carbon, like left side 2 carbon, right side 2 carbon, and here I have 3 carbon and here I have 1 carbon. So these are metamers, but both of them are ether functional group, so they are not functional isomers. So option number D here. Next, identify the correct statement in the following. Okay, dimethyl ether and ethanol are chain isomers. Okay, so let me see you, dimethyl ether and I have been given with ethanol. Are they chain isomers? No. You can see here the ether functional group, here it is alcohol functional group. So these are what? These are functional isomers and not chain isomers. So this statement is wrong. We have to find what? Correct statement. Next, ethanoic acid and methyl methanoate are position isomers. If I see ethanoic acid, okay, and methyl methanoate, okay, sorry, I added, one second, just a minute, yes, methyl methanoate. I have to write, yes. So I have methyl methanoate. This group is what? This is also, are they position isomers? No, here we have different functional groups, so this is also incorrect. N-butane and isobutane are functional isomers? No, these are position isomers. If you know, N-butane is like this and isobutane is like this. Okay, so these are your what? Position isomers, sorry, chain isomers. Here we have 4 carbons and here we have 3 carbons, so these are chain isomers. Propane 1-OL and propane 2-OL are position isomers. Yes, if you see propane 1-OL, I have OH here, and propane 2-OL, I have OH here. Everything is same, only the position of OH is different in both the compounds. So these are position isomers, option number D here. Next, which of the following compound has a wrong IUPAC name? You have to match the wrong one. So if I see this one, this is ethyl butanoate, 1, 2, 3, 4. This part is your group ethyl butanoate, that is the correct one. Here 1, 2, 3. So it is 3-methyl butanol, that is also correct. Now if I see 1, 2, 3, 4. So I have 2-methyl butanol. No, I told you OH is a stronger functional group, so it should get least number. So numbering should take place from this side, 1, 2, 3 and 4. So it should be 3-methyl butane 2-OL. So this is wrong. Okay. Next, if I see here 1, 2, 3, 4, 5 or 1, 2, 3. If I go from this side, I will get this CO is anyway getting 3, you number from whichever side. But if I number from this side, methyl will also get a least number, right? So I can have 1, 2, 3, 4, 5. So that is 2-methyl pentane 3-ONE. So correct answer will be option number C. Okay, the incorrectly matched IUPAC name will be option number C. Next, which of the following represents the given mode of hybridization? The first is sp2. That means it should be a double bonded carbon. So here it is a triple bonded carbon. I can eliminate this option. Okay. Again sp2 means again I should have a double bonded carbon. Here you see only 2 sigma bonds are there. So this is an sp carbon. So I can eliminate this option. Now here I have 3 sigma bonds. Here also it is there. Next carbon is sp. If I see the next carbon, yes, here I have only 2 sigma bonds. So it is sp. But if I see this carbon, it has 3 sigma bonds, right? So this carbon is sp2, which is given here sp, and this carbon is also sp. So option number A. So always remember, if I have 4 sigma bonds, then it is sp3, 3 sigma bonds, then it is sp2, and 2 sigma bonds, then it is sp. Okay. Next, I have when the hybridization state of the carbon atom changes from sp3, sp2 and sp, the angle between the hybrid orbitals. So if you sp3 is tetrahedral, okay. So here the bond angle is 109 degree and 28 minutes. Now if I see sp2, sp2 is like this, okay, and it is 120 degree. Next is sp, you have like this, okay, and this angle is 180 degree. Okay, so as I change from sp3 to sp2 to sp, what is happening? The bond angle is increasing progressively. So option number B. Next, in which of the following homolytic bond fission takes place? Homolytic means equal bond breaking. Okay, so for example, I have X and X. Okay, this bond breaks like this and you will get X dot. That is called homolytic bond fission. So when I have photochlorination of methane, that means whenever we have free radical mechanism, or in case of halogenation of alkanes, there is a homolytic cleavage. If you know the mechanism, you will be knowing this. So option number C is the correct answer here. Next, increasing order of stability of the free radicals. So you should remember, tertiary free radicals are more stable, then secondary, and then primary. Okay, so if I see option okay, I have phenyl groups here. So here all the 3 groups are phenyl. Okay, let me see the options. Okay, if you see the first one itself, you have a tertiary radical and it is stabilized by phenol groups, phenyl rings. Means this option A, the first compound is like this. You can see like this. Okay, so these can stabilize the free radical with resonance very well, right? So that is why we will have option, this one will be more stable. Then we will have this one, okay, where I have 2 groups. Then I have CH3, this one radical, and then I have CH3 secondary radical. This is tertiary radical. So option number A. What is the mistake here? This one should be at the top, right? So that is the mistake here. This is C6H5 whole 2. Next, what I see here, this is also same thing, C6H5 should go front. Here if I see C6H5, 3 should be first, then C6H5 2 should be there. So option number A is the correct answer. Next, in a benzene ring substitution with NH2 group, orientation is controlled by, okay, release of electrons in the system by resonance, withdrawal of electrons through inductive effect, resonance effect which dominates the inductive effect which dominates the resonance effect. So if you see NH2 group is what? It is a electron donating group. So it release of electrons, and by what? By resonance. So when it donates the electrons goes to ortho and para position. So the incoming electrophiles are directed to ortho and para position. So the influence is due to the release of electrons in the system by resonance. Okay. Next, we have identified the correct statement in the following. Dimethyl ether and ethanol are chair isomers. I think we have already solved this question, right? Option number D was the correct answer. So this is a previous year question, 2017. Next, resonance effect is not absorbed. So for resonance effect, what I need? Conjugation. What is conjugation? We can have different types of conjugation. The basic thing we should have is sigma bond, double bond, single bond, double bond. If this type of system is there, we will have conjugation. Next, what I have? Double bond, single bond, and then I have lone pair. Then also I can have conjugation. Or else if I have any carbon plus, and this side we have a lone pair, this also can do resonance. Here I have plus charge, single bond, double bond. This can also give you resonance. So where I can find resonance? Here you can see my single bond, my double bond, single bond, double bond. So resonance is there. So this will show resonance. Here I can see double bond, single bond, again triple bond. So here also resonance is there. Here I can see chlorine is having lone pair. So double bond, single bond, and then lone pair. So this is also possible. Here if I see double bond, single bond, single bond. Okay. So if this group will have lone pair, then there will be resonance, but here there is no possibility of resonance. So option number D here. Next, an miscible liquid of C6H6 and CHCl3 can be separated by. So whenever we have miscible liquids, we can separate them by using distillation method, that is option number B. And if I have immiscible liquids, miscible liquids means when they are completely mix with each other. You cannot find two different layers there. Okay, so that time we have to use distillation. If it is immiscible liquids, then you should use separating funnel. Okay, separating funnel. Next, 29. During Lassine test, N and S present in an organic compound changes to. So if you have studied, Lassine test is done to identify different compounds. So in that, nitrogen gets converted to NaCN and sulfur gets converted to Na2S. Okay, so that is why option number A here. Next, last question. Nitrogen detection in an organic compound is carried out by Lassine test. The blue color formed corresponding to which of the following compounds? So if whenever as we see, first nitrogen gets converted to NaCN, okay, then it forms a complex which is Prussian blue in color, and that complex is nothing but Fe4 FeCN6 whole 3. This compound is formed due to which a blue color is appeared, and we can detect the presence of nitrogen. Okay, so that is why option number C is the correct answer here. Okay. So yes, these were the top 30 questions, students, and I hope you all have answered this question. If you have any doubt in any question, please put down in the comment section. I will definitely address it. Okay, and remember, we have just few days left, so it is now really the time to work hard, to put our 100% efforts. Okay, so please work hard, my dear children. If you have any help you need, do let me know. I'm ready to do it. So, and any other doubts also you can comment down. Any other videos you require, you can comment down. But I want all of you to do one comment that you are going to put 100% of your efforts. See, whatever you have studied before or not studied before doesn't matter, but how are you utilizing this next 10 to 15 days, whatever we have. I think just 10 days we are left. So next 10 days, how you are using it, what you are doing, what things you are avoiding, how strategically you are studying, this matters a lot. So whatever is your level of preparation, please do not worry. Start your preparation from now if you haven't done, and work hard, work smartly. Focus on PU2 syllabus, you will definitely do better, right? So please do not forget to subscribe the channel, because we are going to come with many more videos for all of you. Okay, that's all.